Hello guys, in this video we'll learn and implement gRPC streaming using Rust. So basically we'll stream our response from our gRPC server to our gRPC client. So let's get started. First of all, we'll move to our cargo toml file, and here we need to add a few dependencies. Tonic with latest version for gRPC and Prost for Proto with latest version. Then we need Tokyo for async programming with version as latest and features as full. And then we need Tokyo stream for stream utilities with version as latest, H2 for HTTP2, and then a build dependency which will help us in code generation, which is tonic build, and then we'll build our project. Once our dependencies are added, go to the project explorer and here add a proto directory inside that stream.proto for our structure, skeleton, schema, whatever you want to call it for proto, and then client.rs for client-side code, server.rs for our gRPC server, and build.rs. Here we'll add the code which will help us in code generation. So let's begin. First, adding our proto. So here we will just add syntax as proto3, package as stream, and then service stream. We'll add RPC in a minute. So let's add our message. So stream request. This contains a string message 1 and message stream response. And this contains a string message 1. Let's say a string version 2. So if you want to add additional fields, you can add. And then we'll just say RPC server stream, and it receives a stream request and returns a stream response. And now we'll go to build.rs, and here we will add a little bit of code for generation, which is result unit box dynamic std error and error, and we'll add tonic build, compile proto. So proto slash stream.proto, this is the location where your proto is inside the proto folder. And finally we'll just say OK of unit. Now let's compile our project or load the changes. So it will also do the code generation. Once the code generation is done, we'll go to server.rs and start adding our server. So first of all, let's import our dependencies so we are on the right track. So make sure to add these and also the code for including our proto. Now let's go ahead and write the server side. So type stream result t and result with response t status, and then we'll just say type response stream bin box, and here we'll add dynamic string item and result stream response status, and then we'll just say plus send. So this is to send our response, and here we'll just add a struct pub struct stream, or let's call it eco server, whatever you want to call it. So derive debug, and then here we'll add impl pb stream server, our RPC that we define, and stream for eco server. And here we will add some implementation, one for the type and one for our RPC, which is right here, which was stream server. So it's converted from the code generation, and here you can see we get it. So this we'll just say response stream, which we define just here, the type. And in the stream server, now here we'll add our code for streaming. So first of all, let's print, and here we'll say streaming, and so let's also add client info. So we'll say client connected from and request dot remote address, and then here we'll create a infinite stream. So let's repeat std iter repeat and stream response, which is again through the code generation. So now it will give us two fields, which is message and version, which is again same as our proto. So here we'll add our message, let's say hello from server, and in the version let's say 1.0. and once we add this, we'll just say let mutable stream box pin and Tokyo stream iter repeat, but we want to add some throttling here, so we'll just say throttle duration from millisecond. So let's say after every 200 millisecond, or after every, let's say 500 millisecond. So it will stream the same response after every 500 millisecond. And you can also have dynamic response as well, but since our purpose here is to learn the basics and how streaming can be performed, so we'll just stick to the same response here. And once we are there, we'll just say let and MPSE channel buffer of, let's say 128 Tokyo spawn to spawn a thread, and async move, so add the closure, and here we will add our code. So we'll just say while let some item stream dot next dot await match tx dot send result, and here we'll say status okay item and await. So if it's okay off, then we can just print server response was queued, and in other case, if there is any error, then we can just break. And right here, once we are out, we'll just print saying client disconnected sad, and then after this we'll just say let output stream is equals to receiver stream new rx receiver and okay off response new box pin output stream as self and server stream. So once we have this, now let's go ahead and spin up our gRPC servers. So we'll just say Tokyo man async fn man return result of unit or box dynamic error. So let server is equals to the echo server struct that we added, and printing, let's say listening, and then here we'll just say server builder add service, so pb and stream server new, and here we'll pass our server dot serve, and here we'll just say localhost and port 50051 to socket address dot unwrap dot next dot unwrap, and then we'll just await and unwrap. So that's pretty much all that we need to spin up our gRPC service, and this is to send a stream. So basically, just to recap, what we are doing here is whenever a client connects, we'll just say client connects from the address, and then we are repeating the same response from server again and again after every 500 milliseconds to basically simulate the streaming. Basically, we are doing the stream here, and yeah, and then when the client disconnects, we'll just say client disconnected. But what else we can do is we can have dynamic response sent from the server, and maybe a contract agreed between server and client. Let's say when EOF or end of file or end of response is sent, then the client should disconnect. But here, since we are not going anywhere in those details, so we are sending the same response again and again, and the client is responsible for disconnecting anytime the client wants. Now let's go ahead and add the code on client side. Again, first of all the imports, and then here we'll just add the code. So async fn streaming data client and mutable stream client channel and number, so how many times we want to receive the response, and then we want to basically opt out or disconnect. So let stream client and dot server stream, and then we will add a stream request here, which will just have a message saying hi from client. So we can wrap it in string, and here we'll just say await unwrap into inner, and then we'll just say let mutable stream dot take, so we'll just take 5 or whatever the number you want. So we'll just use this number, and then we'll just say while let some item stream dot next dot await print received from server and item dot unwrap dot message. So this is all that we need, and then let's add our main. So async fn main result box dynamic and std error and error. It's pretty simple, and again, if you guys need the code, just comment down below. I'll be happy to share. Let mutable client stream client and connect to http and same on port 5051 dot await dot unwrap, and then here we'll say println streaming from server or streaming on client, and then here we'll just say streaming data, call our method and mutable client, and let's say first we pass 5, then we'll increase it and see how our code behaves. Tokyo time sleep duration from seconds 1 dot await, and then we'll just say okay of unit. Now let's go ahead and run our server side first and then our client side. So open the terminal, and here we'll first run gRPC server. Actually, before running, we'll go to cargo toml file because we just missed one thing, which is to add bins. So name is, let's say, gRPC server, and path as src server.rs, and then bin name as gRPC client, and path as src/server client.rs, and then we'll build. And now let's go to our terminal, and here we'll run the server. So now let's open our terminal, and here we'll run our server side. As you can see, the server is up and running. Now let's run the client side, and so there you go, hello from server, hello from server, hello from server. We get 5 times, and then client first was connected and then client disconnected. So similarly, let's go to client side again, and instead of 5, let's change it to maybe 10. Let's see. And again, you can see on the client side, server side, first client connected and then the client is disconnected, and there you can see now it prints 10 times. So that's how we can use streaming in gRPCs in Rust, and it's pretty simple to implement and very useful if you have large or huge response or you want to stream data. So if you need this code, please comment down below. If you like the video, like it, subscribe to the channel, and I'll catch you guys in the next video. Thank you for watching. Bye bye.